Okay guys, happy Monday. Now, I am going to go ahead and go over some stuff on the review today. So, I want you to add two things that I forgot last week. I want you to do intensive versus extensive. And I want you to actually look this up yourself and tell me what it means. Very short and sweet definitions. And then I want you to be able to tell me the difference between quantitative versus qualitative. Quantitative is like the word quantity, and quantity means amount, which means numbers. Qualitative is like the word quality. It's words or descriptions, okay? So go ahead and pause the video now and make sure that you get this down into your midterm review book, because remember, this is what you can use on your midterm. All right, we did this last time. And then we went ahead and added some math into, we did sig figs and everything else. Now, we're going to go ahead and move on to periodic table. Now, my book is a little off from y'all, so wherever you left off at, once you finish with those two definitions, we're going to pick up right there, and that's where we're going to start our information. So I'm going to leave a little room because I did write my information on separate sheets of paper, and so I'm going to pick up here. And what we're going to go over today is the periodic table. Now, the periodic table is a resource on your Google Classroom, so make sure that you have that down. Now, the first thing that we're going to go over is going to be the square and what everything in it means. So we have 8, 0, and 15.994. This is oxygen. This is the square on the periodic table. So this right here is your atomic number. This is your element symbol. And this is your atomic mass. Now, the atomic number gives you your protons and electrons. It gives you the number of protons and electrons. Now, to calculate the number of neutrons. So these are your calculations you may need. So to find the number of neutrons, it's going to be your atomic mass, okay? So atomic mass minus your atomic number. So that's the first calculation. So that's the first one. And the second calculation is going to be the mass number. To get your mass number, that's different than the atomic mass, okay? So this is different. It's going to be the number of protons plus neutrons. Okay, so those are the things that you should know off the bat. Now, when we're reading the periodic table, I'm going to say reading PT, as in periodic table, you need to know that when we read across a row, this is known as a period. And when you read up and down a column, this is known as a family or a group. I'm going to go ahead and do that because it can be either way. A big thing is, big thing is, as you read down or up a family or group, they have similar characteristics. At any point, if you need to take time to write this down, pause the video. You can pause the video and start it back up as many times as you need to make sure you get this information. Alright, now I'm going to show y'all how to draw a brief outline of the periodic table so you don't have to print one every time. You're going to do something like this. Now you're going to go down just a little bit. You're going to go over just a little bit, go down a little bit, then go across quite a ways. Go up, over for a little bit, one, and then close it off. So it's kind of one step at a time, draw each piece. So this is a rough outline of the periodic table. You need to know that this and these over here are going to be your nonmetals. They are dull, brittle, low melting point and boiling point, and they are not conductors. There's a bug flying around. Okay, now over here along this line, this is that stair-step zigzag. These are your metalloids. They act like metals and nonmetals combined. So they have properties of both metals and nonmetals. Now, all of this, all the yellow, these are your metals. And they have properties opposite nonmetals. They have properties that are opposite of nonmetals. So these are the ones that are shiny, hard, high boiling and melting points, and they are conductors. Okay? And then we're going to add one more thing right here, from here to here, groups 3 through 12. I'm going to kind of go over it with this green. The reason I'm doing this is these are those transition metals. Transition metals. Y'all can't really see that. Let me find another one. Okay. Transition metals. All right, so go ahead and pause and finish filling this in if you need to. The next thing we need to go over is going to be trends, periodic table trends. Okay, now we're going to make this as easy as possible. I'm not going to draw out every single periodic table the same way. So what I'm going to do is I'm going to say this is my periodic table. Okay, of course it's a little different, but we're going to start with electronegativity. My electronegativity is going to increase as we go this way. and it's going to increase as we go this way. Then I'm going to do another periodic table, not really though, a rough sketch. This is going to be the atomic radii or radius, which is going to be the size. And it is going to increase going this way. I'm going to put INC for increase, and it's going to go increase going this way. So if you go this way, it gets way bigger. So this far corner, super large. This corner, small. And then we're going to do ionization energy. Okay, it's going to increase as we go this way, and it's going to increase as we go this way. So, we also, remember, we need to know that as we go up and down a group or family, the characteristics are very similar. And while we're here, group 1 of the periodic table are the alkali metals. Group 2 are the alkali earth. Group 3 through 12, transitions. Group 7 are the halogens. And group 8 are the noble gases, or inert. Remember that these guys, the noble or inert gases, what's important about them is they do not react. They are already full. They have the right amount of electrons in them already. Okay, next section is going to be the history of the atomic structure. Sorry. Okay, for the atomic structure, we have the history, the people. Okay, so we started with Moseley. He's the first person to make a periodic table, and he arranged them by atomic weight. Then we had Mendeleev. He rearranged the periodic table, PT for periodic table, by atomic number. Then you had Thomson. He did the experiment with the cathode ray tube. And he discovered the electron. Then we had Rutherford. He did the gold foil experiment. Try and get it all fit on this one page. And with the gold foil experiment, he discovered the nucleus. And then we have Bohr, like in the Bohr model. He's the one that said electrons move in fixed orbits. I'm abbreviating as much as I can because I'm running out of room. So, oh, y'all can't even see. I'm sorry, guys. So the Bohr, the electrons move in fixed orbits. Okay, so pause the video and get those copied. All right, the next thing that we're going to go over is going to be how to calculate the average atomic mass. Okay, so what's going to happen is you're going to be given some numbers, and it's going to be like 20% of 64.7 AMU. And this is going to be 80% of 42.3 AMU. And it's going to be for the same isotope. So this might be an isotope of carbon 13, and this is carbon 14. And we want to know the atomic mass. Well, to do this, we are going to have to do a little math. Now, what you're going to do is you're going to start out with this top one, okay? So we need to change this from from a percent to a decimal. So we're going to have 0.20. Move the decimal over 2 places, always, no matter where the decimal is, move it over 2 places to the left. And you're going to multiply by the 64.7 AMU, okay? Then we're going to take this guy and we're going to do the same thing, move the decimal over 2 places, 0.80 times 42.3 AMU. Now, once we get to that point, what we're going to do is we are going to actually multiply these guys and add them up. So, I got my handy dandy calculator right here. So I have 0.20 times 64.7 equals, I end up with 12.94. And then I multiply this second number, 0.80 times 42.3 gives me 33.84. Now, we're just going to add these two guys up. So I still have 33.84 on here, so I'm going to add the 12.94. And it's going to give me 46.78 AMU. And that's your answer. This is your answer. Okay? All right, next thing that you need to know, I know we got a lot to go over on this one, is the isotope. Isotopes have a different number of neutrons compared to the regular guy. And when we have isotope notation, we have the symbol, which is calcium, like Ca. Okay, so we have calcium, and then we have the 40 and the 20. This is going to be your mass number, and this is going to be your atomic number. This is for your isotope notation. Okay, isotope notation, so make sure you get that written down.